In this video, we will learn about the settings down the left-hand side and the templates, which are at the top here. We save a template by clicking the blue save icon here, which opens up the template dialog. So starting at the top, we're just going to skim over the settings and the different sections. Where there's a lot of detail, that will follow in a later video. The first menu, collapsible menu, is the transmitter menu, and here is where you set up the position of the transmitter on the Earth. This is both the location in your defined coordinates and the height above the Earth. In the 3D map, the red line denotes the location and the plumb line from the transmitter to the point on the Earth. So if we had a very high transmitter, it would still be visible even if the icon is not. In this case, we've set our transmitter here, and we are an 8-meter mast above the Earth. The network is demo and the site is A. Make sure you use a sensible network name so that you can group your work together and find it quickly later on in the archive. Now that we're happy with our transmitter location, let's collapse that and move on to the signal. The signal is a PMR 446 megahertz center frequency in this example. We can put in any value from 2 to 90 gigahertz, but if I put in an incorrect value, 1 megahertz, I'm told that is out of range. So let's put in a sensible value and move on to the power. The power can be measured in watts or decibel milliwatts if you're doing a low-powered system such as Bluetooth. For now, we're doing 1 watt, which is 30 dBm. And we can use very large values in there. We can go up to several megawatts if we need to. In the bandwidth, this is measured in megahertz, and we can go from 0.01 all the way up to 200 megahertz bandwidth. When we update the bandwidth, expect a dialog that warns you the noise floor has been set. This is because there's a direct relationship between bandwidth and noise, which we have a blog and demonstration about. The noise floor will vary by location, so this is just a formula, and you will need to enter a better value if you have one. The feeder, if we're using coaxial cable, we're going to experience loss, and so we can change the feeder by selecting it from this list here, and we can change the length by sliding this slider here. So if I had a 30-meter feeder already, I've got 6 dB of loss. By the time I add my 2 connectors, that's increased again, and we've dropped down to 23% efficiency, which happens. Moving on, the antenna menu is where we can select our antenna pattern, and we can choose from templates, or we can build our own custom pattern. This is a big topic, and it will be covered in its own video, which is the antennas video. For now, we're going to leave it as a default dipole with 2.1 dBi of gain. The mobile receive menu describes the distance station. Notice the latitude, the longitude are both grayed out because the distance station in the default mode is everywhere. If we were to use a different mode, such as the path profile tool, these boxes have now become enabled, and that is because we can now select the location for the distance station and say it is here. And we can also select that by entering the location into those boxes. The height is above the ground, so for a handheld radio, be conservative, say it's 1 meter. The receive gain, again, a conservative default, is going to be somewhere round about 0 or 1 dBi. The measured units, there's a choice of path loss, received power, field strength, signal to noise ratio, bit error rate, or RSRP, reference signal received power. For this demo, we're just interested in the default units. We'll cover the rest in the digital modulation video. The sensitivity is where you set the threshold for your distance system. This will depend on your waveform and on other circumstances. If you're not sure, take it from the datasheet or just go with the default value of -90. The model, it's a fairly big topic, propagation models, but what you should understand is they are all curves on a graph and they're all fairly similar in trajectory. They vary in terms of their start and finish points. So the free space path loss model, for example, is a reference model, which is the most optimistic of all because this is as good as you could get. This is why this one has a nice big red warning on it. The default model is the irregular terrain general purpose model, and this one is great for diffraction in cities, especially if you have LiDAR data. The rest of these settings will be covered in the propagation model video. The environment and clutter layers can be manipulated here, so you can turn on and off land cover, buildings, or custom clutter. We'll go into this in the clutter video, but for now we're going to create two templates using surface model and terrain model to demonstrate the difference. So the first one I'm going to create here, just to show that difference, is a surface model calculation. So I'm just going to use these settings here and create a calculation by clicking the green button, and I've received a layer here, so I'm satisfied with that, so I'm going to save that, call it PMR 446 and DSM. That's saved. I'm now going to make one change and change it to the terrain model. So this is the digital terrain model. Repeat with the same settings except for that one change, and notice that we've now got a very, very optimistic coverage compared with the surface model. The reason for this is there are different data sets, and we have LiDAR data here, which is DSM, and then we have terrain data, which is DTM, and it doesn't have the same detail as LiDAR. And as you can see, they produce very different results. Each has their own advantages, which we will cover in the clutter video. But I'm just going to save that template as PMR446_DTM, so you can see and follow the process for saving templates. Finally, the output menu is where we set the actual display parameters. In this case, the resolution was 5 meters used in here. We can go down to 1 meter data if we have the LiDAR data available for cities. Globally, we have 10 meters, so that's a safe bet. If you're doing large calculations, you need to be starting at 30 meters, and if you're doing very large over the horizon calculations, you need to be looking at 90 or 180 meter resolution. So 5 meters is good for here. The color schema, you can choose different color schemas. We'll cover this in the colors video because it's a fairly advanced topic now. We've got so many different units and so many different choices. The radius describes the absolute limit of the calculation. So if I did 1 kilometer radius and I run this, you can see we're not getting coverage out to those distant points we were before. I'm just going to go and put the LiDAR back on so that when I reduce the radius further down to 500 meters, you can see that was a very quick calculation because we don't need to do as much work, and we only went out to 500 meters. And I could also go down to 2 meter resolution here just to show you the difference. So there's a relationship between resolution and radius. It computes a megapixel value, which is described here. You need to stay within your plan because if you start getting above 4 megapixels, things get slow. So generally try and aim for 1 megapixel as a practical limit. Now, we created some templates earlier. I'm going to go and delete one of those templates. I want to delete the DTM template because I don't like the coverage because I've got LiDAR. So I select it and I click delete, and it's now deleted that template. So I only have one template on my list, which is the PMR446 DSM. If I want to save this, I click the download button here, and that template is downloaded now onto my computer as a JSON text file. I can upload that file back into the system here. So I could have put that into a different account, I could share that in my company, or I could upload that on a different system like Soothsayer, which is the private instance of CloudRF. As well as custom templates, we offer some system templates to help you get started with settings. The system templates are available in the templates dialog at the bottom here where it says browse and select system templates. Click that link there and you'll be taken to a new dialog here with a select list. Choose from the list here and there's a list of a variety of different equipment. So I could pick a PMR 446 mobile and I could add that to my list, and I might want a repeater as well. I'll add that to my list, and whilst I'm here, let's go and grab a LoRa gateway too. So this is with the EU parameters on 868 megahertz. Okay, so now I've added some templates on my list. I've got more templates. I have the custom one I created a minute ago, and I have 3 new system templates. So if I pick this LoRa gateway, the color key has changed to a special LoRa key. Let's go and have a look at the signal. It's 868 megahertz. The RF power is 100 milliwatts. You get the idea. By picking a template from the list, all the settings are predefined, and so it helps you quickly establish correct settings in CloudRF.